So our next speaker is Minko Gechev, who, just so you know, decimated me at table tennis earlier today. So I'm still very hurt from this. All right, so I have to make up more stories about you. So when Minko was a child, he was a boy and did many naughty things. Insert amusing anecdote about Minko here. Do you have any amusing anecdotes?
I tried to skip from kindergarten several times.
You tried to skip kindergarten? Escape. So like you went there and you're like, this is not my style. I'm out of here.
Jump out the fence.
Wow, jumping fences, escaping kindergarten. Anyone else have an amusing anecdote about Minko you want to share? Is this like a eulogy? Like, we'll all come up, tell us what he meant to us. The other thing I will tell you about Minko is that he is both a GDE and I would say a really important part of the Angular community. So for years, Minko has been showing up at conferences, giving amazing talks about all the cool things he's doing. One of the things that I love about Minko is that he's always trying to push the state of the art. So at the Angular team, we're really trying to focus on figuring out where the industry is going, figuring out where web development's going, and trying to build the right tools that are really stable, really solid for where the kind of puck is going. And he gets to kind of come along and build on top of us and say, hey, I'm going to look at this problem in a completely different way and come up with a completely cool new solution. And so he's here today to talk about one of those cool, awesome solutions that he's been working on a little bit. So let's give Minko a round of applause.
Thank you for the introduction. And does my microphone works, right? Okay. So yeah, hello everyone. I'm the guy who tried to escape from kindergarten and who is experimenting with Angular. So today I'm going to be talking about one of my experimentations that I did recently, which is predictive prefetching for Angular. And in general, I'm going to explain more of a idea, how I think the tooling actually in the JavaScript community and the JavaScript world should actually happen. So I'm also working on rhyme.com, which is a tool for where we provide a platform that aims to help you build more scalable and consistent workshops and corporate trainings. And all right. And I'm also quite active in the open source community. So some of the projects that I have been working on are Codalyzer, a tool for static code analysis of Angular applications. I worked on Guess.js, which is actually the tool that I'm going to be talking about today, that I'm really excited about. And a couple of other projects, such as the Angular Style Guide, where I had the privilege to work together with Igor Minar and John Papa and a couple of other folks. And I'm also co-organizing the Angular San Francisco meetup. So you're welcome to come there next week, where we're going to have Ilana. We're also going to have Simona from Microsoft. And of course, we're going to have Matt, who's going to be talking about how we can open source an Angular library. Right, so let's get started with the talk. We all know that JavaScript is extremely powerful, right? And the entire web platform is amazing. So we have so many awesome APIs there, such as WebRTC, Web Audio, we have WebGL, everything with web. And after that, what you have seen in native, we have it already in the web platform. And also, JavaScript is extremely fast. Its performance is comparable to native. However, we started building more complicated Angular applications and JavaScript applications in general. So we also started shipping more and more assets over the wire. A couple of years ago, the average web application size is actually became as big as the original game Doom. And DoubleClick did a research that about 77% of the mobile websites take more than 10 seconds to load. And 19 seconds is the load time for the average web application, which is pretty bad. Like, just to show you how bad it is, let's suppose that my blog was taking 19 seconds to load. So you open my blog, and well, you see this. It's kind of an awkward experience. Yeah, we were supposed to be very patient, right? And these were only about 10 seconds. So now let's suppose that we had to wait 18 seconds or 19. That was going to be very, very, very horrifying. In fact, waiting for a slow web application to load is as stressful as watching a horror movie. And on top of that, some of the assets are more expensive than others. I just managed to show how JavaScript is much more expensive than a JPG image, for example. 170K of JavaScript requires more than 20 times more time to be processed compared to a JPG image. That's because JavaScript needs to go through, first, of course, we need to download the bundle. Right after that, our JavaScript needs to go through some process of lexical analysis, syntax analysis, and after that, we need to execute it, which takes a lot of time. Of course, there are some tools which are trying to help us take care of that. For example, we can apply some kind of a compression, right? But after that, we will need to decompress this and again perform all these phases of execution of our code. Facebook recently released Prepack. And Prepack is an amazing tool that allows us to evaluate our source code as much as possible as part of the build time. So that's this way we are supposed to reduce the actual startup, the actual cold start of our application, which helps to some extent, but still it's not the ultimate solution. Because if we're shipping a couple of megabytes of JavaScript, well, we're still going to be slow. So there are solutions which may eventually help us to deal with this. Probably the most efficient one is lazy loading. How many of you are applying lazy loading with Angular? Perfect, yeah. So lazy loading, we're already using that with load children, for example. Lazy loading is a practice which allows us to load only the resources that we need at a given point, and later we download what we are going to need, of course, for this specific page that the user is going to open. So for example, if we suppose that our application has a home and an about page, we can just ship to the user the home page, and right after that, when they navigate to about, we can provide them this bundle as well. There are usually two main strategies for code splitting or lazy loading. We have route-based lazy loading, and also we have component-based one. In Angular, we are usually using load children, so we are using the route-based lazy loading. However, we can go on even lower level of granularity where, for example, let's suppose that we are an online store and we have a chat box. And let's suppose that the users are using this chat box only, let's say, 10% of the time. We really don't want to ship the JavaScript associated with the chat box to each individual user. We can just delay it and instead provide a placeholder. When the user clicks this placeholder, we're going to download all the assets associated with the chat box and make the UI interactive. So that's pretty neat, of course. And often, I guess, we are using lazy loading, but it's also expensive, right? If the user is at the home page and they want to go to about, and about is a page which we load lazily, this means that they need to wait a little bit until the browser sends an HTTP request to the server, gets the about page's JavaScript, and right after that executes it. So whenever possible, we would want to download everything at once, right? We don't want to delay the loading of each individual asset. But how do we usually pick what to load lazy and what not? Well, I have developed quite a few Angular applications now, and not only Angular, I have used other methods as well. And I can say that I'm often choosing what to load lazy on my subjective judgment. I just suppose that the user may not go somewhere, so probably I can delay the loading of the assets associated with this route. Sometimes, of course, this is based on data. So we can look at some analytics platform. We can see that the user visits some specific pages, but don't visit others. So somehow we can decide how to make our code splitting data-driven. But often, when we want to make something data-driven, something being loaded lazily, we would need to switch from a static to a dynamic import. And this is a manual process, and this could be error-prone, because also users, they change their behavior over time, so we would probably want to reflect that. This is one of the problems, and the other one we already discussed. When we load modules of our page lazily, we would need to wait a little bit until these pages get into the browser's memory if the user navigates to a different page. A solution to this problem is using prefetching. So again, with our example, if we have a page with a home and an about route, and we are loading both of them lazily, and we know that from home, the user usually goes to about, well, when the user is at home, we can just on background, fetch all the assets associated with about. That's kind of a straightforward approach. But often in a Wikipedia-like application, from one page we have thousands or hundreds of other links. And we may not want to download everything. It gets complicated. We cannot introduce a manual approach in order to download only the most important assets. And again, we somehow need to choose which pages are going to be with higher priority that we would want to prefetch. So, well, I'm picking the priorities of my bundles this way, usually in a very, very subjective manner as well. I'm just trying to guess where the user may eventually go and make a conclusion based on that. So another approach is, of course, to lazy load everything. That's what I would recommend maybe in a couple of years. But if we lazy load everything, of course, we're going to go get a delay before we want to open each individual page, because we first need to download the assets associated with it. But what about we use dynamic imports for everything, and we just let our tooling to take care of the rest, to choose which chunks should be clustered together into a single bundle and what the priorities of the prefetching should be. We already have our analytics. We already have our statistics in Google Analytics. We only need to figure out how to map the individual pages that we have from Google Analytics to individual JavaScript bundles. So for example, this graph here, we can get it from Google Analytics pretty easily. We have the root page, we have /a, and from /a, the user can go to /a/a and to /a/b. And the thicker given arrow is, the higher the probability for the user is to go to a given page. So given this graph here, we can eventually conclude that we can combine the assets from the individual pages to 3 separate bundles. We can have the A pages into one bundle, the B pages into a different bundle, and the root, of course, into a third bundle. This way, when the user goes to /a, we already know that we already have the assets from the A bundle in memory. So the only possible navigation from the user to go to a different page, which we already don't have preloaded, is the B bundle, right? So we can eventually implement this as part of our tooling, and I'm going to show you already working library. We're going to take a look at actually a little bit in the past because it works with Angular version 5. But anyway, in order to put everything into a context, let's take a look at an existing application that I was working on. So this is Brownie Points. It is an application which I built with Angular a couple of years ago. It uses a lot of different techniques in order to speed up my initial load time. I started it actually with Angular Alpha 40-something. So I went through a very heavy migration process between the individual breaking changes there, before the stable release. And I extracted this navigation graph out of it from Google Analytics. We're going to take a look at this graph just in a little bit. I know it's not too readable right now. I chose a color scheme that I liked, so I want to show it in my slides. But I created a mock of my application, like almost the entire application, just much uglier. So it has the exact same pages, so I'm able to reuse the statistics that I already got from Google Analytics. And here, I'm applying route-based code splitting for each individual route. So when the user opens the application, they're going to download the main bundle and also the bundle associated with the current page. In this case here, login. When they navigate to parents, we're going to send another request over the network in order to download the JavaScript bundle associated with parent, and so on and so forth. This is basically for each individual route. We can, if this is an Angular CLI application, we can just run npm run build, and right after that serve it, serve the static content by using a static server. Now let's also emulate really bad network conditions, because our application is very simple anyway, right? So our bundles are maybe 3-5 kilobytes. So it's going to be hard for me to demonstrate how bet how our application is going to be behaving in a real life. What I did was to introduce a little bit of latency of 1500 milliseconds. So here is what I got. The user first goes to settings. They have to wait. And in the end, they see the settings screen. When they click on home, they have to wait again. When they click on FAQ, they have to wait 1500 milliseconds again. So that's not a great user experience, of course. And I simulated this, but in the real life, it's going to be even more annoying because, well, with 3G network, there might be even more performance issues. If we take a look at our Google Analytics graph, we can notice a pattern here. So the connection between settings and main is kind of very thick. So this means that the navigation between settings and main is quite possible. We can also see that the connection between FAQ and home is very thick as well. So these edges are thick, which means that probably we're going to use these bundles together somehow. A possible optimization that we can do is to cluster together the chunks associated with main and settings, which means that we need to change our route declarations from load children to just a static imports. We can also prefetch FAQ when the user is at home, right? So nothing too special. However, we would need to do that for each individual page when the user behavior changes. And of course, after we change our UI completely, we would need to re-implement all these lazy loading strategies from scratch. So I played a little bit with this, and after that, it turns out that the Chrome team is working on a similar idea. So I started collaborating with Adios Manny and with Katie from his team, together with Kyle from Guess.js, on a project called Guess.js. So we are basically trying to guess where the users are going to go. This is still a very early preview. As I told you, this currently works with Angular version 5 and with Gatsby. In a couple of weeks, if I take a few days off, I will be able to make it work with Angular version 6 as well, and with the CLI. So this was the disclaimer that I had for you. All right, so the first step at the moment with version of the CLI 1.7 is to eject everything because we need access to the Webpack config. And when I say Webpack, it sounds kind of annoying because all of us, we don't want to touch Webpack, right? I mean, I didn't want to. And I had to develop a plugin for Webpack, which was not the best experience that I've ever had in my life. So that's why I wanted to make the plugin in a way that it's as convenient as possible to be used by developers. And all you need to do is just introduce the Guess plugin and pass a Google Analytics ID, view ID, and that's it. After you do that, and you run npm run build, the build process is going to start. Of course, TypeScript is going to go through all the files, perform type checking, and right after that, transpile your files. At some point, you're going to reach the Guess plugin, which is going to open a browser. Here, you can just allow Guess.js to read your Google Analytics data. It is going to, you're going to make him very happy this way. And finally, it is going to perform all the things that we mentioned so far, such as bundle clustering and prefetching automatically for you. And here's how our application would look. So we first open settings, which is instant because settings is already part of the initial bundle of main. We open FAQ and verify, and we can see that we prefetched here FAQ when the user was already at home. Well, this happens automatically, and the cool thing is that when your UX changes, after you run your build, all these prefetching and chunking strategies are already going to be implemented and run, and everything is going to run out of the box. Now let's see how everything works, because I had a lot of fun implementing it. And I hope it's going to be interesting for you as well. So first, there are 3 packages which are collaborating together in order to achieve this result. We have Guess Google Analytics, Guess Parser, and Guess Webpack. The Guess Google Analytics plugin just fetches structured data from Google Analytics. That's it. So you can even use it as a separate module just by importing the fetch function there, and just somehow authenticating, even using OAuth, what we did here, or by providing a JWT. Right after that, we have the Guess parser. This is actually a very fun module. I used the Angular compiler there in order to be able to create the mapping between the Google Analytics data and the actual JavaScript bundles. So it does a bunch of static analysis. We also have the Guess Webpack plugin, which builds some kind of a currently basic machine learning model that you can use in order to query at runtime to see which pages are going to be visited next at a given point, so that Guess.js knows what to prefetch. Here is how the Guess plugin looks right now. Let's ignore the cluster chunks plugin for a moment and focus on the runtime prefetch plugin. Runtime prefetch is basically going to build this graph, the graph of our application. And also, based on the statistics that we have from Google Analytics, it is going to build a Markov chain at the moment. The Markov chain is probably not the most sophisticated model that we can use, but on the other hand, we can compress it pretty well, and it is perfect for our purposes if we want to run it onto the client. We don't have to drag very heavy neural networks and do fancy things. Now, let's suppose that the user goes to the root of our application. If they're at the root, we're just going to take a look at the associated row in the Markov chain and find all the pages which are above threshold of 0.5 of probability to be visited. So in this specific case, we can see that from the root, the user can eventually go to 0.3 probability, which is the A page, or 0.7, which is the B page. In this case, I have chosen a threshold of 0.5. Actually, this threshold can vary depending on your effective network type. So depending on how fast is your network, we can prefetch more or less. This makes Guess.js to some extent adaptive. In this case, we can see that B matches this specific threshold, so we can just prefetch the bundle B. We're downloading B, and now looking at /B. When we're at /B, we can only go to /B/A. So, well, we're taking this guess, and we're not performing any further action because /B/A was already part of the B bundle. Finally, when we go to /B/A, we can see that there is one probability for the user to go to /A. Well, in this case, we can download the bundle associated with the /A route, and that's pretty much it. So in future, there are a lot of possible things which we can improve even further. Each individual user can potentially get a personalized build. So the build for each individual user can be specific to their own behavior, which makes the application fast for everyone, as fast as possible. We can of course do smarter clustering because we would not want to make the bundles bigger than necessary, and which relates to a very interesting algorithm that we'll be working on. We can use more advanced machine learning model. We have been exploring LSTM neural networks, but the tricky part there is whether we would want to actually ship TensorFlow to the browser. We can use, of course, more robust parser as well. And here are a couple of articles that I wrote in the process. Also, the cost of JavaScript. This is an article by Arius Mani from the Chrome team. It's really good content, which explains why we should ship less JavaScript in the browser. And well, I'm pretty sure that in near future, we're going to use more and more data-driven or machine learning approach in order to have better tooling, not only in the web, but everywhere. Yeah, thank you very much.